Hello, Facebook. It's time for a Facebook Live on. Have you seen multiplication like this? Y'all, I'm going to share with you tonight my favorite model for building and solving multiplication problems, building multiplicative relationships and solving multiplication problems. And it is amazing, and you are going to love what you see. So welcome tonight to this Facebook Live. Let's talk about some powerful multiplication, what that can look like. It's not an algorithm. It's about thinking and reasoning, using relationships to multiply with power. And I'm going to share with you my favorite model for doing that tonight. So welcome. Great. We've got a bunch of people coming on. I'm using StreamYard to stream tonight. And so to do, if you wanted to comment, then you need to follow some instructions that show up at the top of the feed that can tell you how you can comment tonight if you want to on this Facebook Live. So super glad to have everybody who's joining in. Look forward to seeing your comments as they come across. All right, so for anybody who teaches multiplication, let's talk about, have you seen multiplying like this? And my favorite model for building multiplicative reasoning and for solving multiplication problems. We're going to dive right in, and let me share my screen a little bit here. Let's do that this way. There we go. Okay, cool. So my favorite model for building multiplicative reasoning and for solving multiplication problems is called the ratio table. Now, what is a ratio table? I tell you what, you guys, if you are my age or not even too far from my age, this could be a completely new thing that you've never heard of. So let's define a ratio table a little bit and then give you some examples of how powerful it can be to solve multiplication problems. So a ratio table is a paired number table. So I could have a paired number table where I might have something like packs of gum, and in that pack of gum there are sticks, and so I might have a pack of gum that has 27 sticks in it. That's a ratio table. It's a special paired number table where the ratios are all equivalent. What that means is that if I have two packs, then I would double the number of sticks in those two packs, and I'll just do that quickly. So then I would have 54 total sticks, and that means that for every entry, let's say I had 10 packs, that would be 276. Every entry, there's still, in every one of those packs, there's 27 sticks. So those ratios are equivalent. Now, I don't just have vertical ratio tables, but I could also have horizontal ratio tables. So I might have one where I might say that I'm talking about pounds, I'm in the States, can you tell, of say candy or something, and then how much will those pounds cost? So I could do something like I might have 4 pounds of candy for $5. That's a non-unit rate, but it's a ratio. And then if I were to find out how much it costs for 8 pounds of candy, that would be $10. Those are equivalent because for every 4 pounds, it's still costing $5. So those ratios are equivalent. You're like, Pam, how are we going to use this to help solve multiplication problems? Oh, just hold on. We're almost getting there. Let me do one more example. So again, horizontal, vertical. I might have something where I might have, I can't read my writing. Oh, yeah. Where I might have something like a bottle of eye drops when I go flying, and you can only have so many ounces in everything. And so I might have a bottle, and if it has 3.2 ounces, then whoo, I can take that bottle on the plane, and there's a vertical ratio table. Now, ratio tables don't have to have context, but it's often very helpful if they have context. I'm actually going to show you now an example of a multiplication problem. Hey, Norma from Buenos Aires. Sweet. Wish I could speak Spanish. Glad to have you here. I'll try to speak clear enough for anybody who's bilingual. Love it. I could speak some German on here. I don't know that we're ever going to have any Germans. We should try to reach out. That's my second language, and even at that, it's not very good. All right, so if I were to give you an example of how we could use a ratio table to solve a multiplication problem, let's do that. So I'm going to give you the multiplication problem of, how about just something random like, I don't know, 42 times 55. That's a pretty standard 2x2 multiplication problem that a student might have to solve. How could I use a ratio table to do that? Now, I'm going to do this in a couple of ways. First, let's do a strategy that I see common in beginning students who might solve a problem like this. So they might say to themselves, I'm trying to find 42 55s. And so in order to do that, they're thinking about 55. So I'm going to do a horizontal ratio table, and I'm going to think about 55s. And I need to find 42 of them. So we might see, hey, Robert. Hey, Kristen, love having you on. So we might see that a student might say, let's say I need 42 of them. Well, I know how to find 10 of them. And so they'll scale times 10. If I multiply that times 10, then I'm going to multiply this times 10. And so we can use that nice thing in our number system to get that to 550. And then that student might say, let's say I need to get to 40. So maybe I'll double that. Doubling is a thing that kids will do right off the bat. So I'll double that. And then let's see, what's double 550? Is that 1,100? And so now they have 20 of them. Ooh, and sort of in that same vein, doubling is kind of a thing that kids might first do. So we might double again. And so these are numbers that I can deal with. I double 20 to get to 40. Hey, check it out. I only need 42 of them. I'm already almost at 40 of them. So if we're going to double 1,100, is that just 2,200? I know I'm going a little quick here, but I'm trying to use numbers that I think everybody can hang on to at first. But say I need 42 of them. So I'm going to need 2 of them. So let's say I can find 2 of them. So I can double from that beginning. If I double that 1 to get to 2 and then double the 55, let's see, that would be double 55. Is that 110? Okay, cool. So now I have 40 55s and I have 2 55s and I need 42 of them. Sweet. I can just add that 40 plus that 2 and that gives me 42. Therefore, I'm going to add the corresponding entries in the ratio table. So I'm going to add that 2,200 plus that 110. Let's see, what is that? Is that 3,000? Sorry. Nah, we did that on purpose. Is that 2,310? Did I do that right? Okay, I'm doing this live. So like, check me guys, make sure I'm going okay. Hey, Bailey. Hey, Bailey. How's it going? It's fun to see old friends. All right, nice. All right, so welcome, Kim. Glad to have you on. So here's a way that we could find 42 55s. I've sort of thought about 55s. I found 10 of them, doubled that to 20 of them, doubled that to 40 of them. And I've got 2 of them. And I'm going to add them together to get 42 of them. And so I'm thinking 42 times 55 is equivalent to 2,310, if I did all that correctly. And hopefully you guys are going to be able to check me a little bit on there. Now, as a teacher, then, I'm going to encourage students to be a little bit more efficient with that ratio table. How could they be a little bit more efficient? Before I go on, I'm going to go, no, I'll keep them. I was going to maybe erase those marks, but we're going to keep them. Hopefully it's not too busy and that you can tell what's going on. But I might try to nudge a student towards more efficient relationships. And so as we nudge students, we use problem strings. That's an instructional routine, problem strings, to help students get more and more efficient with what they're doing. I mean, I know, Kim, I'm super jealous too. I'm so glad that Kim was my kid's teacher and so that my kids were able to experience wonderful math like this. So I might nudge kids to use a little bit more sophisticated chunks. And you might think that's just bigger chunks. And often we do want to encourage kids to think about bigger chunks. But I'm going to show a little bit more of a sophisticated strategy that after kids are sort of working with ratio tables and we do more problem strings with them, then kids can begin to look for even more slick, clever relationships to use. So again, I'm thinking about 55s. That's really messy. Let me see if I can straighten that up a little bit. I'm thinking about 55s, but instead of just 10 and double that to 20 and double that up to get to 40, I'm actually just going to find 2 of them right off the bat. I'm going to need 2 later, right? And so I'm going to find 2 of them right off the bat. That's 110. And then watch what I do. I'm just going to then find 20 of them. Bam. I already need the 2, and I can just scale that up times 10 to get to 20 instantly. And I've got my notifications on, for heaven's sakes. It's not like I haven't done a Facebook Live before. Let me turn that off. All right, no more notifications. Sorry about that. And now that I've got 20 of them, let's see if I'm going to times 10, that multiply that 110 by 10. Is that just 1,100? And so now I've got 20 of them, but I need, oh, you know what? I got a little excited. I don't actually want to find 20 of them. My bad. So I'm going to find the 2 of them. Sorry. I'm going to find I mean, I could do that, but I'm trying to be sophisticated here. So I'm going to find 2 of them. Then I'm going to double to get to the 4 of them. So I'm going to double that to get to 4, double the 110. So that's 220. Now I'm going to scale up by 10 and go straight to the 40. That 4 times 10 is just 40. And so that's 2,200, right? So I got 40 55s, but I need 42 55s. Well, I've got both of those. I've got the 40 and the 2. And so now I will clean that up a little bit. Oh, got rid of my line accidentally. A couple lines. Let me get those back in there. And so now I can just add that 2 plus that 40 and the 110 plus the 2,200. And so that's 42 of them. And again, we land on that 2,310. Bam! That's a little bit more sophisticated. I'm using a little bit more sophisticated relationships. I'm even more efficient. Like I've totally beat partial products at this point. If we're thinking about place place value partial products. What a lot of people do when they sort of do the box method, they split everything into place value and they do all of the parts. That's a fine beginner strategy, but then I want to nudge kids to get more sophisticated, really be efficient. They're really building their multiplicative reasoning in order to use strategies like I just showed. I don't have to have near as many entries, and bam, we're a little bit more sophisticated, right? Have you seen multiplication like this? It's so powerful. Okay, cool. Well, what else could I do with 42 times 55? Could I use the commutative property to think about 55 42s? Why would I want to do that? Well, y'all, I'm trying to share with you this favorite model of mine. So let's just sort of do this problem another way and kind of get you a better feel for how ratio tables work with multiplication. So 55 times 42. Now I'm thinking about 55 42s. So now I'm going to focus on 42. And I'm going to go ahead and do this one vertically. So I'm going to focus on 42s, and I know I need 55 of them. The only reason I did horizontal earlier and vertical now is because I want to give you a look at both of them. We would want to do both with students. We want to give students experience with both vertical and horizontal. They're going to see both. They're going to use both. We want them to have facility with both. Now, one's not better than the other. It's just really a different look. In fact, before I move on and talk about 55 42, some of you guys are probably starting to solve that. Go ahead, and then we'll come in. In my workbook, Lessons and Activities for Building Powerful Numeracy, we have several what we call workouts, and they're Blackline Masters to build powerful numeracy. And you might notice in Lessons and Activities, in fact, that's right. That's that book right there, Lessons and Activities for Building Powerful Numeracy. All of the ratio tables in the book are horizontal. And you might think, oh, therefore they all should be horizontal. You know why they're all horizontal? It's totally real estate. It's like, how many can you fit on the page? And I can fit more on the page typically if I do them all horizontally. And so I make sure when I present that I do some vertically, and so that teachers see both, and we need students to see both, so that when you do like problem strings, you would want to do some vertical ratio tables, since the workouts, the problem talks, were more horizontal ratio tables. All right, let's get right down to thinking about 55 42s. Oh, Kristen, cool. Glad you like the workouts. I love them too. I'm so glad that I had some middle school teachers nudge me to create them. I'd never thought about creating them until some middle school teachers said to me, Pam, can you give us something that we can like hand out that will look official? And so we created a bunch of Blackline Masters. They're super awesome. Okay, cool. So 55 42s. Well, I've got one 42, but I need 55 of them. So could I, if I need 55 of them, 50, that's kind of like I bet I could get 100. Like if I do 100, that's pretty doable, right? So 152s, I'm going to scale that times 100, 42, sorry. I'm going to scale that times 100. So 42 hundredths, right? So I have to know this thing about times 0. That would definitely be something that we'd have to, times 0, times 10 times 100, and the thing that happens with 0. We'd have to have worked on that with kids a little bit to use this. But now that I have 100 of them, can I just cut that in half to get 50 of them? If I can cut 100 in half, and then, hey, check it out. Some of you are like, cut it in half. Yeah, but 4,200 cut in half? Isn't that just 2,100? Bam! I've got 50 of them. Okay, now I still need 5 of them. 5 of them. How am I going to get 5 of them? Well, could I just scale from that 50? Can I just divide by 10? 50 divided by 10 is 5. And so now I've got to divide that 2,100 by 10. Well, there's that 0 thing happening again. Is that just 210? Okay, so far I've got 50 of them. I've got 5 of them. I'm going to have to add those guys together, that 50 plus that 5. So I'm going to add that 210, 2,100 plus that 210. And does that give us 55 42s is again that 2310. What do you think? Huh? Pretty nice strategy. If I just think about the problem a little bit differently, I am going to go ahead and clean this one up because I need some space over here, because I'm going to do this problem a slightly different way. So there's one strategy for finding 55 42s. Let's do another one. Now I might nudge students when they sort of start with that strategy. I might nudge them to, again, another sort of more sophisticated strategy. Oh, nice, Amy. Cut it in half. Yes, nice. All right, cool. So Amy's already shown her strategy. Maybe don't look at the comments quite yet, or I'll have to look. I didn't look. Totally, Amy, that would totally work. Nice to get to 25 and double to 50. Oh, I'm not showing that one. I'm doing a slightly different one. So first strategy, we found 100 to cut in half to get to 50. What's another way to get to 50? Well, could I start with that 1 to 42? I'm thinking about 42s. I'm going to get to 5 instead. So to do that, I'm going to go to 10. So scale times 10, 42 times 10 is 420. And now I'm going to cut that in half. So I scaled times 10. And now I'm going to cut that 10 in half to get to 5. And so I'm just going to cut 410 in half, or 420 in half. And so is that 210? Now I've got 5. Now check it out. Now that I've got the 5, can I just scale that up times 10? Bam! Right? Once I have the 5, I can just scale that times 10. And now I'll have the 50. So what is 210 times 10? There's our 2,100 again. And now I add that 5 and that 50 together. So I'll clean that up a little bit. So add the 5 and the 50 together to get 55. And so again, I add the 210 and the 2,100 and we get the 2,310. All right, you guys, one more. Middle school teachers, I would want to nudge kids towards this last strategy. This is a much more sophisticated sort of way of dealing with it, but it can be really slick and handy. And so middle school teachers would be nudging students to think about the same problem, but with slightly more sophisticated relationships. So again, I'm dealing with 42s. I want to find 55 of them. I'm thinking about 50 of them, 5 of them. Oh yeah, I know something about 1/2. What? 1/2? Yeah, I'm just going to find 1/2 first. So I'm going to divide that one by 2. And so I'm going to divide the 42 by 2. That's going to be half. And so is that just 21? Okay, what, Pam? Why would you find half? That's crazy. We need 55 of them. We don't need to go smaller. We need to go bigger. Come on, go big. Well, once I'm at 0.5, can I just scale that times 10? And now I'm at 5. That's our 210. And now that I'm at 5, can I just again scale times 10? And now I'm at 50. And so that's the 2,100. I add those together again and I get 55. Bam! I mean, y'all, those are sophisticated relationships. And think about our middle schoolers. We need them to think about the power of 1/2 and how 0.5 is related to 5, is related to 50. Like those are powerful relationships. And so this is kind of a way of sort of looking at a progression. If you've ever heard anything that I do, I don't do this very often. We try to do something new all the time. And so kind of figure this is a little bit of a new bent on what we do. Sort of here are kind of beginning strategies that students might use, and then a more sophisticated strategy if I'm thinking about 55s. Or if I'm thinking about 42s, a beginning, a middle, and kind of a most sophisticated strategy. And again, we kind of let students solve problems however they do, but then we do problem strings to help them get more and more sophisticated and more efficient. All right, let me look and see what people are saying. Once you can see multiplication by 5 is related to having a number, that might be even better. Yeah, Robert, right? I mean, it's so cool. And it's a great relationship. For sure, I never built as a student. I didn't build it until much later in life, proving we can all be mathematicians. We can all mathematize more than we ever have before if we do real math and really focus on multiplicative relationships and connections and not memorizing algorithms. Yeah, let's just look at the examples that I have up here quickly. Thinking about this problem, 42 times 55, using the commutative property, 55 times 42. I want you to notice that if I had some students that were solving that problem and they were using a ratio table, notice how I can sort of see their thought process. Like it's made sort of visible that I can go, oh yeah, I can totally get kind of the chunks that you're using, what your brain is sort of playing with, kind of what your goal was. There's a goal. Students kind of have to know what they're thinking about. When they look at a problem like 42 times 55, if they're going to think and reason to solve it, they have to choose. Am I going to think about 42 55s? Well, you can see that I did that if you look up at these two. I was thinking about 42 55s. I was thinking about 55s, and then I found 42 of them. Or was I thinking about 42s, and I wanted to find 55 of them? Well, then I'm going to use these strategies. These are me thinking about 55s, and I'm finding 42s, and I'm finding 55 of them. That's a window into your student's head. That helps me as a teacher, as I'm circulating, I'm seeing students work. I totally know what you're thinking about. I'm seeing a lot of students in my class use, say, this very first strategy up here. Let me do it this way. This first strategy up here, well, then I'm going to do some problem strings to help them sort of think about, ooh, is there some way that I can get from 2 and 4 to 40? 4 to 4, 2 gets me to 4, gets me to 40. Ooh, I can kind of plan ahead. If I see a student using this strategy up here, that's typically a student that just sort of trudges forward. Okay, all right, I'll do what you tell me to do. I need 42 55s. And then you sort of start building from what they know. Now, they're using fine relationships. But then I want to kind of help students sort of start to plan ahead. Like, do I want to find 42 55s? Or might I want to find 55 42s? And then once I've sort of decided which way I want to which factor I want to kind of mess with, then I can kind of have a goal, like what's the best way that I can think of to find that 42? What's the best way I can think of to find that 55? And then based on the other things that we've done in class, I kind of have some relationships to lean back on that I can use to help me get more and more sophisticated. As a teacher, I might do a problem talk where we might share a couple of these strategies and then step back and have the conversation. Which one's more sophisticated? Why? Which one's more efficient? Which one do you wish your brain would do next time? You guys, if you take one thing from this Facebook Live tonight, which one do you wish your brain does next time? Look at that growth mindset. That's growth mindset. Oh, I want my brain to do that next time. So as students are sharing different ones and we're comparing different strategies, I want to nudge students towards more efficiency by putting up more efficient strategies and then saying, ooh, what about this is more efficient? Having the conversation, having students go, oh, I can see. Okay, cool. And then we can do other things to help them sort of build those relationships, and then let them solve the way that they do, and then continue, look at their work and then wonder. So for example, I might look at this top strategy up here. Say I had a student do this less sophisticated one. I can see their process. That's part of the beauty of the ratio tables. I can see the chunks they were working with. And I might say, hey, it's kind of interesting that I noticed that this 20 and this 2 seem really related. That's interesting. Like you did some work to get to 20. You had to find 10 to get to 20. And you also needed the 2. Interesting that I wonder if we could just use the 2 to get us to a 20, or 2 to get us to the 4 to get us to the 40. Like that's interesting. Like I might want to notice these relationships and then let those kind of come out as students then solve problems in the future. All right. So I have a surprise for you if you wait to the end of this Facebook Live. So hold on tight, because I have an exciting surprise that I'm going to tell you about, all about thinking about how we can use this model called a ratio table to really build multiplicative reasoning and solve multiplication problems. So hang on for a surprise. All right, let me see what people are saying over here. This is great for calculating sales tax. Absolutely. And tips. Absolutely. Colette, very cool. You just started learning how to do this. Nice. I can't wait to share with your students too. That's so incredible. It's so powerful when students start to realize that math is figure outable and that they can just use what they know to solve problems, and they don't have to search for rote memory, and they don't have to the time pressure of thinking about the facts that they tried to rote memorize. And all of a sudden we just free them up. Like, what do you know? And it's okay to figure things out. Notice that almost nothing on here was like a fact that I knew. I just used relationships. I double, I multiply times 10. I cut things in half. Those are all sort of relationships that kids can build and then just kind of use to solve problems. And Kristen, I'm glad you like the question, which one do you wish your brain would do next time? We like that one. Sometimes kids can maybe beware that kids might go, oh, like yours is better than mine. Oh, you're better than me. Okay, I'm not good and you're better and whatever. And in that moment, I want to be really like, oh, wait. Do you like that? You like what this person did? You like this other strategy? You want your brain to do that next time? Then I'm giving the student, I'm sending the message. You have that. Like you have the capability. You own that relationship. Your brain could do that next time. It's within your zone of proximal development. Of course, I'm not going to say that to students, but I'm going to hey, do you get that? You see how cool it is? Well, sweet. Let's have your brain do that next time. You want your brain to, as soon as I get a kid to go, yeah, I want my brain to do that next time. Now they're high-fiving each other and they're like, ooh, nice one. I want my brain to do that next time. Now we're a really positive building atmosphere using such a cool model called a ratio table. So again, what's a ratio table? It's a special paired number table where all of the ratios are equivalent. Now, I can definitely have different paired number tables where the ratios aren't equivalent. Think of all of the paired number tables that you used in high school and all of the different functions. Many of them are not ratio tables. So it has to be that the ratios are equivalent. So we can do some really cool things with ratio and proportion with ratio tables. We can also do really cool things with division with ratio tables. Yeah, I told you there was a surprise. So are you ready? We have for you, I'm so excited. I'm going to offer a webinar coming up on 2 weeks, Friday, January 22nd and Saturday, January 23rd, totally free webinar, all about this ultimate model that you've been waiting for, the ratio table. So it's totally free live webinar. These Facebook Lives are short. I'm going to end here in just a minute. On the webinar, it's longer. I go into more detail. I take questions. You can ask questions on the live webinar. We'll also record the live webinar so that in case you can't make it, something comes up. I know you guys, teachers, your time right now is so precious. You have so many crazy things being demanded of you right now. I totally get it. So we will go sign up for it because we'll record it and then we'll send you the link and you can totally watch that live webinar because we will have recorded it. So show up and you can have your questions answered live. We'll go into more detail. We'll talk about how ratio tables can be used for multiplication with more examples like I just did and talk about the strategies that are possible. We'll talk about division on a ratio table, and we'll also talk about solving proportions on a ratio table. I mean, this tool is so versatile and so powerful. You are going to absolutely love this live webinar. Y'all, will you do me a favor? Will you share this? So on the Facebook page, we've, oh golly, have we put it out there yet? We're going to have a post on the Facebook page that will talk about the webinar. And then will you share that? Share it with your friends, share it with your colleagues. Let people know. We'd like to get as many people as we can, as powerful as we can, teaching real math. We really want to affect the way math is taught and the way math is perceived and the way people perceive themselves as mathy people or not mathy people. We want people to know that they're all mathy people. Everyone can do more real math than they can fake math. And we believe that and really want to spread that message. And so if you'll do me a favor and help people know about the webinar coming up, maybe take a picture of it. I'm so lame. So let me surprise you one more time. Let's see. I'm trying to think of, hang on. Okay, I can. Technology is my friend. So here is the web address, the URL for you to go to register for the webinar. So you can do it right now. Mathisfigureoutable.com is my website. When you type in math in your computer, Math is Figureoutable should come up. Why? Because you go there all the time, right? So your browser is used to pulling that. Okay, so start the habit. Mathisfigureoutable.com/webinar21. Maybe somebody could put that in the comments. We'll put it in the comments and we'll pin it to this Facebook Live so you can see that link right away. Click on that link really quickly. Just choose the Friday or the Saturday. We'll send you a congratulations, you're in the webinar email. Later, another surprise, we'll send you a really cool note-taking sheet that you can print if you want, or you can use it on a tablet and you can take notes during the webinar and you can have a record of everything that you learn. So if you register for the webinar, you'll get that handy-dandy note-taking guide. You'll get access to the recording after. So if you don't mind helping to spread the word, I would love it. Let me go back and check comments and say thank you, Kim, for putting the link in the chat. Y'all, ratio tables are so cool and so powerful. I hope you've learned a little bit about multiplication with ratio tables. Help me spread the word so we get more and more people to be more and more powerful with math, because math is figure-outable. Thanks so much for being on tonight, everybody. Loved having you on. Appreciate it. Share the word. You can share this Facebook Live. It'll be here on my Facebook page forever, and you can share it with all your friends, and then they can hear about making math more figure-outable as well. Y'all have a great evening. Thanks for joining me.